All right, last video we talked about how we got started in cables, or how I got started in cables, because it was pretty much me, and me at the beginning, and what led to the company we are today. This video, I'd like to talk more about the sound of the components within a cable. Again, I'm sure with some people this is controversial. For me, it's not, because I've taught myself how to hear them. And there's a lot of people that just appreciate the cables, you know, what we make as a whole, as the cable sound. It's kind of like cooking to me. You have ingredients here in these cables, you know, for example, here we've got a conductor material, whatever it might be. Let's call it a copper alloy. All right. We've got dielectrics, all right, which in this cable happens to have Kapton and Teflon. We have filler materials, which in this cable, there are no filler materials. It's a see-through. In fact, purposely designed this cable to let people see what's inside of it. No secrets. This is a Captivator light. And this clear urethane jacket is a material. All right. It actually is a deadening material. It prevents vibration from traveling along it. And the durometer is set up and so on to be flexible, yet have multiple purposes. It's not just for shielding the cable. And then, of course, you've got connectors, which we don't make the connectors, somebody else does. All right. In this case, it's Wattgate. Within this cable, let's focus on one thing at a time. Let's start with the conductor material. All right. And I'm just going to list off the top of my head what I can change in the specifications of each of these things. All right. I'm telling you that because I've done this for decades, that every change will have an effect on the overall character and sonic traits of this cable when placed into a high-resolution, high-end system. Let's start with, say, the conductor materials. All right. First of all, you can choose what you want the conductor to be made of. In our case, with a lot of our cables, we have custom conductors made. All right, but let's just pick on, say, copper. Just because I say the conductor is copper doesn't mean that all copper conductors are made the same. You can choose the quality of copper, the percentage of copper, the purity of the copper. Some people went crazy and came up with a way to choose coppers from various mines in the world, which I don't know about that. I didn't go that far. But just saying that you have the ability to spec the quality and the purity of the copper. And that does change the clarity of that conductor, or what the conductor is capable of conveying. Purity matters to a point. All right. There used to be a 99.9999% race going on with conductors, and you really find it when you do this, when you design cables for a living. There's at some point you got enough 0.9s there, and enough places after the decimal point where it's really not going to matter anymore, because other factors come into play with the sound of the cable. So really, you can go overboard with that one if you wanted to, and marketing, of course, tended to do that. Anyway, just the conductor material alone, you can see you can choose the material. There's the most popular ones are copper and silver. We've gone with a blended alloy wire that uses a high purity aluminum and a high purity copper. And we could vary the percentages of the two metals and how they relate with each other, along with the annealing points of the conductor. And of course, gauge size and strand count and size within the conductor. These are all things that can be specified just for the conductor. And again, over the years, I've learned what works for our cables and what doesn't, and what sounds better and what doesn't. So you hone in on a recipe. I talked about cooking before. To me, this is kind of like cooking. I have my ingredients. I'm going to put together a cable. I think you'll find that if you took 10 chefs and gave them the same ingredients and told them make this dish, they'd probably all taste different. And that's kind of the way it is, because there's so much subtlety to this that can be done in between that's unspoken. So we just started with the conductor for one. All right. Let's talk about the dielectrics, or the insulation over the conductor. All right. You have plenty of choices there, literally dozens and dozens of acceptable choices on how to insulate the conductor so that one doesn't touch the other one and short out. You have to use some sort of insulation on these wires, right? The internal wire. So there's things like polypropylene, polyethylene, PVC, nylon, Teflon, various grades of Teflon, PETs, Kapton. I can go on and on. Bottom line is there's plenty to choose from. They all have different specifications, and sonically they all sound different when applied on a conductor. And so again, it's one other ingredient and that you get to choose from when cooking up a cable. Not only can you choose the dielectric, you decide in a specification how it's applied to the conductor. So for example, let's say you have a solid core conductor. It's no stranding. It's one solid wire. You can coat that wire with an enamel or polyimide or any of these very thin coating, just enough to insulate it for the job intended, right? You can extrude on that wire where the wires run through a machine, through a die, and the molten plastic or the dielectric is actually applied right to the conductor. And you can also decide on how it's extruded to the conductor. You can do a tubular extrusion, which means there's basically a hollow tube is created out of this that spaces itself in the conductor so the conductor somewhat floats inside the hole in the center, all the way through to a pressurized extrusion where you're actually forcing the insulation material onto the conductor. And particularly with a stranded conductor, that really acts differently because you're forcing it into the strands themselves. And again, all these different variations in specifying how just the insulation's applied affect the sound, overall sound of that conductor within the cable. So now we have a conductor or a choice of conductors. We have a choice of dielectrics so we can apply to the conductors to insulate them and how to do it. So the next thing is, what do we do with these conductors to make a cable on? And so now they can be, the conductors can run parallel to each other in just straight line. They could be twisted in some way, or what they call cabled. Do we apply a shield over these conductors or not? What kind of insulation do we put over the conductors to hold them in place? Are there any fillers or anything are placed inside or in between to either expand or move the conductors apart from each other or make the cable seem larger than it really is? All these things are available options to making a cable. And of course, we also have color choices too, right? We can make this cable any color since we're having it custom made. Would you like blue, black, golden, white? Your choice. With colors do come some variables, like with a white cable, you've got to make sure to have the proper additives done to a cable. Otherwise, it will turn yellow over time from UV exposure. Any of the lighter colors will turn a different color over time. So you've got to also specify the type of insulation being used and any additives necessary to protect it from UV. So there's a lot to consider when you're designing a cable. It's not just about the sound. These are all objectives that you must specify if you want a cable made. And trust me, when you go to a company that extrudes plastic for a living onto wire, they have no idea about this. They can't help you with it. They can't, oh yeah, we know what makes this sound better. It doesn't work like that. They look at it as a blank slate. You tell us what you want and we'll make it. They have no input whatsoever. You have no help on this matter. That goes for any of these manufacturers. Their job is to make the conductor to specification, insulate a cable to specifications, make the cable to specifications. They have zero knowledge of this. So you're on your own when you try to have something custom made. And the thing is, you're spending a fortune having it made. It's expensive. You have minimum runs you have to make. And you can't just have 10 feet of a custom conductor made. It doesn't work like that. All right? You're going to have thousands of pounds of it made is what you're going to have, minimum runs. So you better make the right choice. Otherwise, if it doesn't work out for you, you're stuck with it, right? Bottom line is that there's a lot of possibilities in designing a cable, which I think is one of the reasons you see so many different cables out there. Every one of these manufacturers has their own idea of how to make a cable and what it should sound like. And the variables are, when you look at all the variables, obviously the possibilities are damn near endless. Anyway, we've honed in on a recipe that we pretty much follow suit through. We've got our own conductor material that we call alumaloy that I've refined over the years, and it is a combination of a number of metals. It's made specifically for us. Nobody else has it. and it sets up what we consider the base sound of the cable. And we build it out from there. To talk a little more on topology of the cable, we should probably get into shields too. That's one big misnomer in terms of a word, shield. When people, coming from an RF background, I'm intimately familiar with how shields interact with the cable, with the environment, and how the environment affects the shielding of a cable and obviously the signal it's carrying. In the field, when you deal with communications gear, whether it be cellular systems, trunking systems, high power RF, radio towers, you name it, there's a ton of problems you run into on new installations and existing. And invariably, they have to do with noise. Most of the problems become mechanical or something, somebody screwed up a connector, somebody bent a cable somewhere or stepped on it up on a tower. The antenna took a lightning hit. There's mechanical issues that occur. But typically on a newer setup, there's all kinds of issues that occur where the stuff was designed to work together, and when you put it together, it doesn't work. Now you got to make it work. All right. It's not like you go back to Motorola and say, hey, can you make us a new radio because this one ain't working? You're like, right, it worked on the bench. It works here. We designed it to work. You must have a problem out in the field. So these are the type of things you run into that when you put together systems, which in audio, that's what we're doing. It's not just one part. It's the sum of the whole parts. When you put together systems, you start to find that things interact, and typically in a negative fashion. They don't necessarily work together well. They don't, for whatever reason. And you got to figure out why and make it work. And so problem solving is a huge thing when you're in the real world with product. And it's what I've applied to audio. It's the same thing, is that you've got a majority of people have a mixed bag of gear, different manufacturers, preamps, amps, CD players. They're putting it in an unknown electrical environment in the home, right? A lot of the wiring isn't the greatest in the world. Plugging it into unknown voltage and noise sources and power supply. And, do you have a sine wave coming out of the home, or is it flat topped? Do you have DC offset? There's so many problems in the AC environment in the home. And you just look at that, you say, it's amazing some of this stuff even works, right? Together. And, so that's what we're after, is like, to me, it's more of a holistic approach. It's like, let's take a look at what we could do with these cables that help these products work together, even though they weren't meant to. They weren't designed together. They weren't designed in the same building. That company made that preamp. This company made that amp. Those speakers are made by another company. And we need to interface all this stuff, so that it works. So now we take it one step further and say, not only is it going to work, but we're going to try to get it to be as clear as possible to the source material. How clear of a path can we create with these various cables placed throughout a system so that we can maximize the ability to hear the original recording? That's the goal. It's always been the goal. And you work toward that in enough years, knowing what you can do with cooking up a cable in terms of the materials used. And the goal's endless, but you do reach a point where it gets so good that now the gear is the culprit more than the cabling. And anyway, I'm getting a little more off track here, but I really wanted to cover on this episode about how the various ingredients or various materials you can get for cables, how they change the sound, and what's available to manufacturers of a cable. And there's other factors involved. We've got temperature characteristics and so on. There's a lot of specifications to the material that aren't necessarily important for audio because we're using it in a home environment. But bottom line is that consider the fact that you can mix up these ingredients or different ingredients in different ways and come up to an overall sound given that mix. Thanks for watching this portion. We'll have another part next time about the sound of all these different materials. Take care.